Welcome back to Mad Science Mondays. Hello, Professor I. How are you?
Good. How are you, Professor L?
I have had a wonderful week, and we're so glad to be back here with our next set of simple experiments for you to try. We're going to have two today, all right, because they're pretty simple. And for the first one, the materials that you're going to need are just access to some water because you're going to have to fill up a glass. So if you have a sink close by, just fill up your glass. You're going to want to fill it all the way to the rim, and we'll do that in a second. This is our safety bucket in case something goes awry or wrong, but we're not expecting it to. And then you need a piece of cardboard. I just cut this out of a box that was handy. I think you could use cardboard off a cereal box or a piece of cardstock. So whatever you have at home, you want to cut it so it's at least as big as the mouth of the glass, okay? So if you have a big wide glass, you might need a little bit of a bigger piece of cardboard. All right, so this is called gravity-free water. Do you know what gravity is, Professor I?
No, do you think you can tell me what gravity is?
I'm gonna try. Okay, gravity is a force, and if we did not have gravity on this earth, you and I would be floating around just like the astronauts do when they go out into outer space because there is no gravity. But there's a gravitational pull on the earth, and so everything that goes up must come down. So if you remember our scientific method, we're going to ask a question, we're going to observe, we're going to draw conclusions, okay, and then try to explain the science of what happened. All right, so are you ready?
I'm so excited.
Okay, for gravity-free water.
Ooh.
So first of all, Professor I, if you would pour water into this glass, fill it all the way up to the rim. And if it spills, well, it's water. We'll just wipe it up. No biggie. You might want to set the glass down and then just keep going. That might be perfect. Okay, for the next part of our experiment, we're going to set this piece of cardboard on top of your glass.
Okay.
Okay, here's the question. If we turn this glass upside down, what can happen? What do you think will happen? I mean, I know what I think will happen. Okay, so here's what I would do, Professor I. I would just hold my hand here so it's easy to turn.
Okay.
But we're going to put this container under it just in case.
Just in case.
Okay.
Okay, so you're going to turn it upside down, and I'll put this right under it as you do it, okay? Are you ready?
Should we count down?
Yeah.
Okay.
Ready?
Ready.
You count.
3, 2, 1.
Now let go of the cardboard.
Let go of the cardboard.
Let go of the cardboard.
Ah.
Let go.
Oh my God!
What?
What is going on?
Okay.
Is this a magic trick?
It's kind of a magic trick. All right. So remember, we filled that glass all the way up to the top where there was no air left in the glass. None. Okay? Then we turned it over. We kind of held that just to turn it because it would be hard to turn without holding the cardboard. Put this under it just in case it didn't work. This is called gravity-free water. That water should be pouring out.
Yes.
Do you know why it is not?
No.
Do you ask me why?
Why? What is going on here?
Okay, well, inside with the water has some pressure. But outside of the glass, we can't see this, but there is a force called air pressure. We can't see it, but we can feel it if we do this. We feel that air moving, okay? That air pressure is stronger than the water pressure inside the glass. And since there's no air pressure inside the glass, it just held the cardboard onto the glass. It sealed it up. That air pressure is holding the water in the glass. Is that amazing?
This is so awesome.
That is so amazing.
You should trick your friends and family with this.
We could have said abracadabra.
Yes.
Okay, so that experiment is called gravity-free water. All you need is a glass, a piece of cardboard, and water. and a safety net, just in case.
Just in case.
Just in case something goes wrong. Okay, are you ready for experiment 2?
Yes.
All right, so we're gonna turn that one back over. Okay. Hey everybody, this is the second part of our experiment today. This experiment is called Sink or Float. So we're going to ask you some questions to see what you think, and then we're going to do our experiment, okay? Are you ready, Professor I?
I am ready.
Okay, we're going to talk about 2 vocabulary words today. The first one is buoyancy. And if you've ever had a toy boat in the bathtub, you know that it floats on top of the water as it's supposed to. That is because it's buoyant. It has less mass than the water that is holding it up. So it's the ability to float in water, or it could be some other fluid. Buoyancy is floating on the water, okay? The next word we want to talk about, and this is a big word, is density. And all objects, and today we're using oranges, all objects have a density. It's their mass, okay? And when an object is more dense, when it has more mass than another object, the water, it should sink. So we have 2 oranges here. So your materials that you're going to need are, I would say, a clear bowl of water. This is the biggest bowl I have. It's actually a measuring cup. You could use a much bigger bowl. It probably would work even better, but I want you to be able to see. So just a bowl of water. And I have 2 oranges. I've got an orange, and then I peeled this orange because it's part of our experiment and I wanted to save some time. So here is my question to you. I want you to feel that orange. Is it light or is it heavy?
It's heavy.
It's pretty heavy. So if we were to put that orange in this bowl of water, is it going to sink or is it going to float?
I think it's going to float.
You think it's going to float?
Yes.
You don't think it's heavier than that water?
It might sink.
Well, now you've told me both. It could float or it could sink, and you are right. It could float or it could sink. Let's try it. Let's put that orange in the water.
Okay.
Everybody, have you thought about it? What do you think it's going to do? Is it going to float or is it going to sink? It is floating. It's floating. What? I would have guessed sink because it's a really, really heavy orange, okay? Now, you know, oranges have something called a rind, okay? And this is a rind, and I'll show it to you up closer in a second. I have peeled the orange, and I peeled it down where really all you're seeing is just the orange part. Underneath the rind, there's some white material. I tried to get as much of that off as I could. So now, of course, if you take the peel off, would this be lighter or heavier?
I think it'd be lighter.
Well, I think so too. I mean, look at the size. It's much smaller now, and they start out about the same size. So if we put this orange in the water, is it going to float to the top like the other orange?
No, I don't think so.
Why?
We've changed. We've made a change.
I know we've made a change, but there's less mass. So is it going to be more dense? That's a hard word. Is it going to sink to the bottom or is it going to float? Are y'all ready? Have you made your guess, your educated guess? Are you ready to try it? Let's see what it does, Miss.
Can I
Professor
place it in the
I.
water? Oh!
Well, there you go. It's in the water. Did it float?
No!
It sunk. What? What? Why would it sink? It is less mass than this, but it sunk to the bottom. It's not floating on the top, not like this guy who's just floating right up on the top and bobbling around. Can you see it? Okay, we're going to try to explain why this guy who's heavier, more mass, floats, and this guy sinking down to the bottom. Okay, I'm going to hold up this piece of rind that I peeled off of this orange, and I hope you can see it. And of course, if you have oranges, you can just look at them at home. And the oranges have little pockets of air on their rind, okay? So when we put this one, this orange with its rind still intact, those air pockets help to hold it up. There's air pressure, and it's holding it up. But when we remove the rind, there's no air pockets. And so the orange is very heavy. It's heavier than the water pressure that we have here, and it just wants to go right down to the bottom. It just cannot float on the top because it is denser than the water. So you can try this at home. I think you could try it with lemons. They kind of have that sort of peel also.
Yeah.
If you had lemons at home, or a lime.
Limes, lemons.
Yeah, whatever might have little air pockets. We don't think about it, but there's all sorts of little air pockets on this rind. This mass is denser than this. Even though we have a rind on this, we don't have one on this. The air pockets make it lighter, I guess is an easy way to explain it. Okay, want you to try it at home. If you want to, send us pictures of your experiment. You know, and sometimes experiments don't work perfectly, but in this case, it did work for us. Okay, well, we'll see you next Monday at 4:30 for our next experiment, okay? Bye, everybody. Thank you so much for tuning in.